Hi everyone, my name is Vinesh Raghavendra and my magic number is B122310284 and my teammate is Tan Pin Chuan. We are going to elaborate about the lab 5 electromagnetic waves and also we are from group BERT section 2/2. Okay, we start with the objective here first. The objective is discover and understand the wave properties and behavior. To predict the behavior of waves through varying mediums at the reflecting endpoints and understanding the standing wave. Okay, we start with the damping result first. Okay, first of all is the lots. It shows the energy is lost quickly, causing the wave motion to stop in a short time. Okay, we will see at the simulation here. Okay, we set into the 1 centimeter amplitude and the tension we decrease into the 20% and damping into 100. Okay, start. Okay, what our source says, when the damping is high, the medium absorbs energy very quickly. As the result shows here, the amplitude drops rapidly and the oscillation also die out in a short time. The wave motion almost stopped. The energy is disappeared, mainly has heat. This explains the wave looks like it fades away quickly in the simulation. Okay, we get into the light damping here. Okay, the light damping, okay, as per the same, just the damping we adjust into the 25% here and then 20 tension. Okay, start. Okay, what shows here, the light damping. With the small damping, the wave loses energy slowly. Amplitude gradually decreases and the oscillation also continue for a longer period. The motion is still visible but weaker. In real life example, we also understand that this is similar to a string slowly quitting down after plucked. Okay, and we get into the non-damping. Okay, it shows here we set the damping into the 0 and run. Okay, what happens? If there is no damping, we can see that we can understand that there is no loss of energy. Amplitude remain constant. It means the wave maintains a uniform amplitude. Okay, this represents an ideal condition which does not occur in reality, but it used for theoretically. Okay, we get into the next part. It is tension. Okay, the first of one is the high tension. Okay, the damping also the same, 0%. We increase it to 80%. Okay, what you guys can see here, it is when the tension is high, wave speed increase. The wave travel faster and the wavelength becomes shorter if frequency stays constant. That you guys can see here. Okay, and then we physically the string is tighter, so there is no disturbance travel more quickly. Okay, this one is the low tension that you guys can see here. We set the tension to 20%. Okay, what is there explained here is the wave travels more slowly and has a longer wavelength at the same frequency. Okay, what does it mean? When the waves that is shown here, the wave speed decreases and then the wave travels slower and the wavelength become longer for the same frequency and wave motion appear looser and more flexible. This happen because there is restoring force to pull the string back. Okay, we go into the next one. There is end condition, the image you guys are seeing here is the fixed end. Okay, this one, the reflection causes a 180 phase intervention of the wave. Okay, there is a zero tension, and also you guys can see here. Okay, we change it to the fixed end and run. Wait on. Okay, you guys can see the difference around here. Okay, what they are speaking about is show around here. At the fixed end, the boundary cannot move. It means the reflected wave is inverted, and you guys can see the 180-degree phase change. A tuff return as a crest. This happened because the boundary applies an equal and opposite force to the wave. Okay, we move to the loose end, the final one. I'm explaining for my part is here. The reflection occurs due to the difference in impedance between the two media. Okay, it means I run for you guys. So seeing the result, so I have to fix it to the loose end, so you guys can see the difference here. Let me refresh here. Sorry. Okay guys, you guys can see here that this is the loose end showing here. It's explained that reflection occurs due to difference in impedance between two media. Okay, it means, wait, I run the simulation here, you guys can see that. It means the loose end, the boundary is free to move. The reflected wave is not inverted, as you guys can see here. There is no phase change occurs. It means the end moves with the wave, so if does not reverse direction, with no boundary, there is no reflection that you guys can see here. Energy continue to move outward, and also this represent an open system where energy is not written. I also, you guys can understand that this is a short real life connections around here. I hope you all understand about my presentation here, and I will continue to my partner next to me. It is Tan Pin Xuan. Thank you guys.
Hi, I am Tan Pin Xuan, and now I will discuss the 5 key findings from our result. The first one is properties. First, we confirm that the amplitude represent energies. We also found an inverse relationship between frequency and wavelength. As frequency goes up, wavelength goes down. Okay. Next is our comparison. We observe that a fixed end flip the wave upside down. And the loose end reflect it upright. We also see that the damping remove the energy like friction. And the tension directly control the wave speed. Okay. By freezing the wave, we identify that tension is the main factor affecting the speed, while frequency determines the circle length. And for the next one is indefinite travel. We demonstrate that by removing friction and removing the boundaries, energy is conserved, allowing the wave to travel forever. Okay, finally we generate a strong standing wave at 1.25 Hz, And where measured, we can measure it, use the ruler, and we can see the wavelength is 5 centimeter. Using the formula V equal to frequency lambda, we calculate the speed to be 6.25 centimeter per second, which was confirmed by the stable node and empty nodes. In conclusion, this lab helped us to understand the nature of electromagnetic wave. We learned that EM wave are transverse wave, means they oscillated perpendicular to their direction of travel. And next is, unlike the string in our simulation, EM wave do not need a medium and can travel through a vacuum at the speed of light. Next, we also explore the electromagnetic spectrum, ranging from low frequency radio wave used in communication to high frequency gamma rays used in medicine. Overall, we successfully met our objective by analyzing wave behavior, reflection, and standing wave. Thank you.